Assalamualaikum and hi everyone. Today we will learn on the derivative of composite function. The learning outcomes of today's lesson is to differentiate the composite function by using the chain rule. Let's say we have a composite function such as y is equal to 1 minus x squared powers of 7, or maybe we can have fx is equal to 1 over x squared plus 3x plus 5 powers of 5 and so on. How are we going to find the derivative of that function? Are we going to expand it? Are we going to expand it for 7 times? Or how? So actually we can solve it by using the chain rule that we are going to look in the next slide. Now we will discuss on the derivative of composite function by using the chain rule. Let's say we have y is equal to u powers of n, whereby u is equal to fx is a differentiable function. Therefore, if we differentiate d per dx u powers of n, okay, we will get it as n u powers of n minus 1 du over dx. Right? So it means that we need to know what is the u, and after that we need to find the du per dx and we substitute in here. So therefore we get the differentiation for d per dx u powers of n. And it can also be written as in other forms. Okay, if we differentiate fx powers of n, we will get n fx powers of n minus 1 multiplied with f prime x. So these are called as the chain rule. Okay, so we will use the chain rule in this part, okay, to solve some examples in the next slide. Okay, let's say we have y is equal to x powers of 3 minus 2x plus 1 powers of 7. If you can see that the y, it is in terms of composite function. So let's assume y is equal to u powers of n. And if we still remember, the dy dx for this case is n u powers of n minus 1 du over dx. So now here, okay, what is the u? So this is the u, okay, something inside the bracket. So u is x cubic minus 2x plus 1. Okay, and the du per dx, we differentiate that one, we get it is equal to 3x squared minus 2. Alright, now we want to find the dy dx. Okay, so therefore dy dx, we are going to use this formula. Alright, so it becomes 7 u is 3x powers of 3 minus 2x plus 1 powers of 6, and the du per dx is 3x squared minus 2. Alright, and if we rearrange that, we get 7 3x squared minus 2 multiply with x cubic minus 2x plus 1 powers of 6. So that is the dy dx for this question. Here we have the y is equal to square root 1 minus 5x. Okay, so if we write back, we can write it as 1 minus 5x powers of half. Okay, so we need to write clearly the value of n. Okay, so if we compare it with the composite function y is equal to u powers of n, so the du per dx, the dy per dx would be n u powers of n minus 1 du over dx. So in this case, we need to determine the u first. So u in this case is 1 minus 5x, something inside the bracket here. Okay, something inside the bracket here. Okay, so this is the u. Okay, and the v is sorry, we have no v here. Okay, alright, so the du per dx, okay, du per dx is negative 5. Okay, now we want to find the dy dx. Okay, finally, what is the dy dx? Okay, dy dx will be n, okay, n u n powers of n minus 1. So we get here this formula, we use this formula, so therefore we get here is as half, okay, u is 1 minus 5x powers of negative half, okay, n minus 1, half minus 1, we get negative half, du over dx is negative 5. Okay, so if you write back, we can write it as negative 5 over 2 1 minus 5x powers of half, or we can also write as negative 5 over 2 square root 1 minus 5x. So that is the dy dx for this question. Okay, let's say we have a question here. Okay, fx is equal to 4 times 4 divided by x squared minus 2x plus 3. Okay, so if you write back, we can write the function fx as 4x squared minus 2x plus 3 powers of negative 1. Okay, so if you look at here, if we compare with the basic composite function, y is equal to u powers of n, so we get the dy dx is equal to n u powers of n minus 1 du over dx. Alright, so in this case, what is the u here? U is the x squared minus 2x plus 3. Okay, it comes from here. Okay, this is the u here. Okay, and the du per dx, okay, differentiate that one, we get 2x minus 2. Okay, now we want to find the f prime x here. Okay, so if you look at the function for f, we have 4 in front of it, so we have to consider that. So we take 4, put it 4 here first in front of it, and after that then we take the formula for composite function here. Okay, then we can have it n is negative 1. Okay, the n is negative 1, and u powers of n minus 1, so we get u is x squared minus 2x plus 3, negative 1 minus 1, negative 2, du per dx is 2x minus 2. Okay, so we get that one. So if we rearrange that, we can get negative 4, okay, 2x minus 2 divide by x squared minus 2x plus 3 squared. Alright, so if you look at here, we also have the same factor 2 there, we can take out here, so we can have negative 8x minus 1 divided by x squared minus 2x plus 3 squared. So that will be the f prime x for this question. Okay, let's say we have y is equal to x 1 minus 2x powers of 4. Okay, let's say we want to find the dy dx of this function. So if you look at here, the y, it is a multiplication between x and 1 minus 2x powers of 4, so therefore we need to use the product rule here. So in this case, okay, we will choose the u. In this case, the u is the x, okay, and the v is equal to 1 minus 2x powers of 4. Okay, so the u comes from this one and the v comes from that one. Alright, and then next we want to find the u prime. Okay, your u prime, okay, it is equal to 1, and v prime, okay, we use the chain rule, so we get here 4, okay, 1 minus 2x powers of 3, okay, multiply with negative 2, or if we write it back, we can write it as negative 8, 1 minus 2x powers of 3. So that is the v prime. Okay, so now if we write the dy dx, okay, so we write the formula for product rule. So we have uv prime plus vu prime. Okay, we will substitute uv, u prime and v prime, so therefore we get here ux, okay, so negative 8, okay, 1 minus 2x powers of 3 plus with u is v is 1 minus 2x powers of 4 multiply with 1, alright, u prime. Okay, if you look at this one, okay, both side we have factor 1 minus 2x, okay, this one powers of 3, another part powers of 4, so the same factor is 1 minus 2x powers of 3, so we take out the 1 minus 2x powers of 3 here. Alright, so here to get this one, we have negative 8x, okay, plus, okay, 1 minus 2x. Okay, so we get this one. So if we write back, we have 1 minus 2x powers of 3, and this one negative 8x plus 1 minus 2x. So we get here 1 minus 10x. Alright, so if we write back, so we have 1 minus 10x, 1 minus 2x powers of 3. So this is the dy dx for this function. Okay, here are some exercises related to the derivative of composite function using chain rule that we have discussed in the previous slide. Okay, you can try the exercises at home, and we will discuss it in the next class. And here also some other exercises you can try. Okay, that's all for today. So see you in the next class.